and welcome to week 2 of EELE 101, and this is the C programming part of the course. This week we will be looking at data types, and the data types that we will examine here are characters, character arrays, which are known as strings, integers, and two types of floating point data types. These are floats and doubles. Okay, so let's look at characters. Now, the first things to mention is in a computer system, all information is stored in memory somewhere. Okay, and uh, a basic data type would be, okay, how would I store a letter? And let's say we had a small computer, okay, because we're not representing much memory here, okay, and our hello world, right? Where would we store that in memory? So a data type that stores letters is known as a char or a character, okay, and we can create a variable that will store letters. In this case, we have the variable name letter. Okay. Now in our code, rather than having to remember where in memory this is stored, we can just remember the variable name letter. However, if we go over here into the memory map, let's say for argument's sake that letter is placed here at memory location 2. Okay, so this is what the compiler and linker would do is would be say, oh, we need a spot in memory for storing a letter, which we are going to call this mailbox in a sense, letter. Okay, now it can store any kind of letter, and so later in our code we will actually assign it to be a particular value. In this case, it's the letter H, and then H is placed at that location in memory. And characters are just 1 byte, they're 8 bits. You can have more advanced characters, but we won't worry about that right now. Okay. So the code here, when we say um, character letter, this is a declaration saying create a variable that is going to contain a piece of data that's only 1 byte, and uh, the bit values are going to conform to this ASCII chart. Okay, so this was created way back in the 60s, where letters are um, 1 byte or 8 bits. Today there's Unicode where there's 32 bits, so we can store all the characters in all the languages. Okay, but we're not talking about Unicode here. We're just going to use ASCII. And ASCII stands for the American Standard Code for Information Interchange. Okay, so what's really happening here is when we type letter equals H, what we're really saying is, well, if we go to the ASCII table, here's H. Okay, it's saying H is represented by the hex value 48, and this is hexadecimal. Okay, and in binary, okay, the 4 is just 0, 1, 0, 0. This represents 4, and 1, 0, 0, 0 represents 8. Okay, so this entire binary string would be placed in memory, okay, where letter has been assigned, and that's where its spot is in memory. Okay, so that's the character data type. Okay, we're just talking about a single character here. Okay, well, a sequence of characters is called a string. Uh, the interesting thing about C is all strings end with a null character, essentially this /0. Okay, so when we want to create a spot in memory that holds all our characters, we have to count all the characters that we're going to put in there plus the null character. And that null character is important because the printf function and other string processing functions just keep going until they see that null character and stop. So if you happen to put in a starting point and it's at the wrong place, it could just be wandering through memory until it finds this null character, which wouldn't be what you want it to happen. Okay. Now, for our purposes, let's create a spot in memory that will hold the string hello world. Okay, so hello world is 11 characters if we're counting the space in between. And we also need the null character at the end, so we need room for 12 characters. And so we will say, okay, here, all right, we're going to create a character. The variable name is string1 here. And now we have these square brackets that tell the compiler to reserve room for 12 characters. And that last character is the null character. Okay, so this is how it would look like. So string1 is the name of the array. It actually points to the first location of where the string starts. It now has reserved space for 12 characters or 12 bytes, and that has been done for us. Okay, and if we make the assignment, the compiler actually also puts in the binary values for those letters. Okay. Now here we were saying, okay, we know how long the string is, but let's say we didn't want to have to count it each time. Well, we can actually leave out the number inside the square brackets, just specify the string we want, and the compiler will count it for us and put that in memory, including the null character. Okay, so we will want to print strings. Okay, so we will use the printf function, but we need a special command code that says insert a string at a particular spot. Okay, so this command code is %s. So in our printf function, okay, we say, I mean, we could have other characters and other letters and words inside the double quotes, but wherever the %s is placed, okay, it's going to insert whatever is contained in string 1. So it says, oh, okay, we need to insert a string here. String 1 is going to be inserted there. All right, okay, string 1 starts at this location in memory, and so it just starts inserting that in the printf until it hits the null character and stops. And then if you had other things like the /n, it does that as well. In this case, it's the new line character. And that will start a new line. Okay, so that's how we print out strings. So okay, so we need to specify %s and then the name of the character array that is holding the string. Okay, so there are a number of string functions already written for us. Okay, and if you want to find out more about those, you can look in the reference guide for these. Here's a few of the commonly used ones. Okay, so let's first create some memory space here. We're allocating a spot that could hold up to 99 characters because we still need the last one to be the null character. Okay, and now we can have a function that will copy a string into that location. Okay, so we have the string copy or strcpy function. All right, so the first argument is the character array where we want the information going. That's where it's going to be written to. And then here we're actually specifying the actual string. This could be another character array that it's going to pull out of and stick into this one. Okay. All right. Well, let's create a second string. So here's string 2 that has the numbers 1, 2, 3, 4, 5, and 6. Okay, these are just the ASCII um, equivalent, the numbers. We will get into integers later, so these are not integers. These are characters. Okay, and now we can concatenate or append strings together. So let's say we just want to add one string to the end of another one. Okay, so to do that we need to use the string cat function. And in this case it has two arguments. It will take whatever's in the first string. Um, well, that's the destination string. It will take whatever's in string 2 and put it at the end of string 1. Okay, so it actually removes that null character, puts in string 2 right at the end of string 1, and then adds the null character at the end. And that's because string 2 already has that. Okay. To use these string functions, we need to have the include file string.h, which is the header file that defines these functions. Okay, so here is some code where let's actually do this. Okay, so you can actually write this code in and run it. So you should actually do this right now in your C interpreter and run it. And before you actually hit the run button, can you predict what it's going to do? And then when you run it, did it do what you expected it to do? Okay, so you should actually run this now. All right, so moving on, at some point we will actually want to get input from the user. So the user may want to type some text into the computer. So how do we get it? Okay, so first we need to reserve room for anything that gets typed in. So again, here we're leaving or allocating room that's going to be up to 199 characters plus the null character. Okay, and now we are going to use the fgets function. And the fgets function requires 3 arguments. Okay, the first argument is the location of where to put the text that got entered. Okay, in this case, it's going to be string 1. Okay. The next argument is what's the maximum number of characters that we can actually put into string 1. Okay. Um, these functions used to not have this, and this was actually, if you were trying to break into a computer, you would do what is known as a buffer overrun, because this wouldn't check and it would actually run over other stuff. But here we're saying, well, we can't put more information into the array than the size of the array. So this is why we use the size of function of the string. So it's going to say at most we can put in 99 letters into the string. If you type in more, it won't do it. Okay. And then the last argument is where is the data coming from? So in this case, it's standard in, which is typically the console window where you would be typing your information. Okay. Okay, one thing to note here is when you hit the enter key, there's a new line. Okay, and that's also in the string, and so later on we will fix that um, because we'll need some if then else control statements to get to the last character and remove that new line character. Okay, So you need to try this out. So go ahead and enter this program to see how you can enter text into your program. Okay, so run this and see what you get. Okay, so this brings up the first programming assignment. Okay, so what you need to do is write a C program that will do the following. First, you need to ask the user for his or her first name, and you need to put this into a character array that is called first underscore name. You need to do this for the last name as well, and store this in last underscore name, a character array. The size of the character arrays, you just need to make sure that they're big enough that any name you type in will work. Okay, so now you need to create a third character array called full name. Okay, so the size of this array needs to be twice the size of the previous two. Okay, and then what you need to do is copy the first array to this third array. So copy the array first name into the third array full name, and then you need to concatenate the last name to this third array as well. So what you'll get is this full name that has both first and last names in the string. Okay, and then you need to print it out and see what you get when you type in your first and last name. Okay, so this is your first programming assignment. Okay, so let's look at another data type. These are called integers. To specify an integer, we use the keyword int. Okay, and ints can be a little tricky because the size of them will vary depending on what CPU you're targeting. Okay, if it's a 32-bit machine, the int will be 32 bits, but if you're targeting microcontrollers that are 8 or 16 bits, these can't hold numbers that are as large as 32 bits. Okay, so just something to be careful about if you're porting code from one machine or one computer to another that has a different CPU in it. Okay, now the integers can be modified by the keywords signed, unsigned, short, and long. Okay. All right, so let's first look at signed and unsigned. Okay, if it's a signed integer, that means it can be negative. Okay, so if we're talking about a 32-bit variable, so we're assuming you're running this on a 32-bit machine, it can represent integers from minus 2 billion to plus 2 billion. Okay. Now, if you specified unsigned, then you're saying I'm not going to use negative numbers, so I want to go from 0 to a little over 4 billion. Okay, short means, okay, it's less than the full integer value. So in this case, if we're talking about a 32-bit machine, a short int would say store the integer in 16 bits. And again, if we're talking about a 32-bit machine and we say a long int, then we want the integer to be 64 bits. Okay, so to print out an integer variable, we need a special command code, and this is %d. Okay, so in our code here, we're saying we're going to have two integer variables, I and j. Let's assign 5 to I and 6 to j. And then we want to print out the integer I equals, well, we want it to print out 5, but here we need to put %d, and integer j equals, again, %d. And then we need to pair the first %d will go with the first argument I here, so that's where we put in the variable, and then the second %d here will get tied with the second variable. So these are paired, these goes in pairs in order. So whatever command code, it just looks for the next argument to put it in there. So if you lose count and mismatch it, you can get some weird uh, errors that come out of that. Okay, so another thing that you'll want to know about is when you type in a number, that's only comes in as a character, character array or a string. And we need to convert that to an actual integer. So we need to use some conversion functions, and we can convert a string to an integer by using the a2i conversion function, and we also need to include the standard lib function that allows us to use that function. Okay, so here, try out, you should enter this program in your C interpreter and run it. So here, prompt the user to enter enter a number, in this case a 6-digit number. So this number gets returned and will be in string 1. So notice string 1 is a character, so that's a character data type. We want to convert it to an integer. Okay, so to convert the string to an integer, we have to use the a2i function, where it'll take the string as the argument, and then it'll assign the actual integer value to k. Okay, and then you can actually print it out as an integer. Okay, well, we've covered characters and strings and integers, but sometime in scientific computing we want to represent very large or very small numbers, and you can't do that with just integers. So what we have to use is something called a floating point data type, and there's a single precision version and a double precision version. Okay, a float is represented as 32 bits, and the way it represents the number internally is you have a certain number of digits times a base with an exponent. Okay, so the exponent can be positive and negative, and that's what allows us to represent very large and very small numbers. Okay, so for a float, which is single precision floating point, we can represent numbers plus and minus 2 to the minus 126, okay, all the way up to 2 to the 127th power. So the approximate decimal representation would be 10 to the minus 44 all the way up to 10 to the 38. Okay, that's the number range we can represent. Well, sometimes that's not small enough or large enough, so then you'll need to use a double precision. So this is a double that uses 64 bits, and the decimal approximation here would be 10 to the minus 323 all the way up to 10 to the 308. So that would be a much bigger or smaller number. But the trade-off is we have to use twice as much memory to represent that. Okay, so if we want a variable that's a single precision, we would say float and then the name of our variable. If we want a double, we would just give the keyword double and the name of the variable that we want. Okay, so we will want to print these out as well. So in this little code snippet, we define A as a single precision floating type, and B as a double. We're going to assign 5.3 to A and 0.00002 to B. And then we want to say the float A equals. Okay, now we have to use the special command code for a double or a float. It's the same for either one, and this is %f. Okay, so now we need to say A equals %f and B equals %f here, and now we tie the variables A and B. So A will go with the first one, and then B goes with the second %f. Okay, and so this is how we can print out floating point numbers. Alright, so we'll also want to convert a string to a floating point number or to a double. And we can do this the same way, except we now, instead of A to I, which is ASCII to integer, we do A to F, which is ASCII to float. Okay, so again, we can enter in a real number, and then we can call the conversion function that will convert the string to the, in this case, K is a double, and this will convert it to a double precision data type. And then you can print it out with the %f, which gets tied to the variable K. All right, so this brings up the second programming assignment. The first 4 is just going to be very much like what you've done before. You just have to ask for a name, first name, store it in a character array, ask for last name, store it in a character array. Now you want to ask for an age. Okay, right now you want to store it into a character array. Okay, you want to ask the user to enter the value of pi, as many digits as they can remember, and store this into a 4th character array. Then you want to convert age, which is a string, into an integer. Okay, so you'll store this in an integer variable, so you have to declare that integer variable. And you're going to do the same thing with pi, except you're going to convert it to a double and store this in a double variable. And then you will print all this information out in a single printf statement. So a single printf will need to print out the following: first name, last name, who is 25 years old, entered the following number for pi, which would be 3.14159, and however many digits you entered. Okay, so in this printf statement, you'll need to use 2%s because you have 2 strings, first name, last name, and you'll need 1%d because you have an integer for the age, and then you'll need a %f because you are now going to print out a double as well. Okay, so this needs to be done in one printf statement. And that's it. So good luck with your programming assignment.